Good morning, everybody. Great to have you here for our Cairns Hardware Meetups launch. And I'd like to welcome everyone here who's on site and also our online guests. As a way of introduction, my name is Dr. Samantha Horseman. I'm the HDR Innovation Industry Lead across James Cook University, and I reside at the Graduate Research School. And it's great to have you all here for not only our launch, but we've got an incredible agenda today. And I'd like to also start by acknowledging traditional owners of the land on which we meet today, the Gumoy, the Wallabara and Udinji peoples. And I'd also like to pay my respects to elders past, present and emerging. We do have a great agenda lined up. So those that are online can also join in. So make sure you have your phone close by in case we need to move and leave the building in case there is an emergency. You can follow me out to our meeting area. It's just out in the front area. And you'll follow Ramona, who you saw as you came in, and she'll guide you to that area. She's very trustworthy. Follow Ramona, don't follow me. Anyway, back to our agenda for today. We'd also like to appreciate the Cairns AI Hub. And behind me, you see our main sponsor, the Queensland AI Hub for this event. But we're also delighted to be able to launch in Cairns, one of the global cities of the hardware meetup, which is really great to be able to do that. And bringing together ecosystem members, whether you're a student, whether you're a researcher, whether you're an innovator, whether you're an inventor, and working on hardware deep tech. So it's great to be able to launch today the Cairns City chapter. And a little bit about our Cairns chapter is that we're one of 32, we make the 33 cities around the world where we have a hardware meetup. And there's around 30,000 members globally. So this is fantastic. And why we know about this hardware meetup, and you'll hear a little bit more from Mike, one of our panelists today, who launched the Sunshine Coast hardware meetups. But we've also got the idea around starting this work through our Vegas trip to the Consumer Electronics Show in January this year. And we met the Australian delegation, along with Victoria, who was one of our founders, Vicky, who was also there at CES. And we came across a group of amazing Australians that recognized that at CES, Australia, in the hardware department and also in the AI department, was missing in action. There was no representation of Australia. And so with that in mind, a group formed from the Australian delegation to create what we call the Australian Creative Electronics Society. And you'll be hearing from Joe, the president, and he'll be giving us an overview about how we're driving a lot of our hardware and deep tech. So it's seen, there's incredible work across our ecosystem. And I guess some really dynamic founders have come together to create the Australian Creative Electronics Society. So you'll hear a little bit more about that, but that's why we feel very passionate about starting the Cairns chapter. So what I'd like to do now is take us through the next version of like that, of our agenda. And I'd like to all put our hands together, both online and here. I'd like to invite our panelists. We're going to start off with a panel, and then we're going to move into the showcase of all the societies that we have that are supporting and resources. So we get to see resources and we get to see a panel, and then we have a draw for a winning option for IEEE and the Australian Computer Society. We'll do a draw, and following that, we'll also have a chance to network and lunch. So that's the agenda today. We hope you enjoyed interfacing and experiencing some physical AI from Kim Bender, the founder of IOTIS and IntelliSense, AgIntelliSense, who created, using Raspberry Pi 5, a motion detection sensor with a interface of avatar that was created again by another founder here in our Founders in Residence, X-Tech AI, Ismail. So a lot of the technology you're experiencing in deep tech today is representative of our founders and residents here at JCU. So I wanted to make sure I did a shout out. So please, let's welcome our panelists to the stage today. We have Dr. Stephanie Baker, a senior lecturer, electronic systems and IoT engineering from James Cook University, who is empowering tomorrow's engineers. Round of applause. And also does great work with the engagement. She's the engagement lead for engineering here at JCU. I'd like to invite Mike Black, also known as Chief Thundermaker, founder from Rainstick, is innovating in deep tech and bioelectrics for agriculture. Welcome to you both. And then we have Darren McCormack, the manager of the Cairns Manufacturing Hub. Please come to the stage, who's shaping the manufacturing agenda here for us today. So we've got a great insights from manufacturing. And we've got Dr. Alan Lewis from the Energy Queensland MIST, Advancing Sustainable Energy Technologies from Energy Queensland. So welcome, Alan. So we've got a great chance to ask a very seasoned panel around a lot of questions around deep tech and also the idea about starting a hardware meetup in Cairns. So I'm going to start with, so sorry I'm here because we've got online and I'm going to be passing the mic down. So I thought I'd position myself here. I'd like to start with you, Steph, because we started to have a conversation around responsible AI. And I know that that's very passionate to you, but also we had a great discussion because there's already a lot of audience members here that are working on medtech and medical apparatus and medical devices. And I'd like to hear some of your thoughts around responsible AI and looking at, you know, what should we be looking at in relation to medical? Thank you.
Thanks, Sam. So yeah, as Sam said, I'm kind of across a few spaces, but the two biggest ones for me are medical AI and using that responsibly. So from the angle of responsible AI, it's really about making sure that the AI systems we work with are safe, they're reliable, they preserve privacy, and also factors like they're fair. In medicine, that's a particularly important one because a lot of data that we have can be kind of affected by things like historical biases. So making sure that when we then train AI models, they actually don't carry forward those biases and apply it to the modern day is a really important factor. Some of the ways that we can try to make sure that they're working in a way that's fair and also reliable is to use explainability approaches. So these are a whole range of different things. It could be things like applying a heat map to an image of MRI scan and seeing what areas the AI focused on when it determined what was in that scan. It could also be things like mentioning which features it considered to be the most important. So did it consider like heart rate and age to be the most important things when detecting a heart attack, for instance? And all of those sorts of things give us a bit of insight into what's happening inside the black box of AI, which is really important for firstly making sure the AI is actually following what we would expect. So one example in my research, we looked at mortality risk prediction. And one of the factors that it found was linked to that mortality risk was age. And we know that to be true. We know that's an established thing in medicine. So we could therefore place a little bit more trust in the AI and that it was working. And also then the other features that it highlighted as important were things we can investigate further. So I guess that's probably a good introduction. Is there more you want me to dive into there, Sam?
No, I think that's great, and some really great important facts. And I know that I don't know if Sarch is here, but he's working on some very specialized AI plus also hardware in relation to skin lesion detection. What advice would you give him in relation to looking particularly from responsible AI lens?
Yeah, so I guess it depends on exactly the type of AI that's involved, but I would say across this concept of physical AI, really that's the majority of AI. There's not really able to be AI, especially in healthcare, without sensors. And even when the AI is just making a decision for the doctor to then go act on, that's still having a physical real world impact. So those aspects of reliability, transparency, making sure the clinician can actually understand and trust in the AI and the decisions it's making. That's kind of the most important thing with any med tech, I would say.
Great insights, and I'll make sure I pass it on to Sarch, who's busy working on his invention. And Steph brought up a great concept on physical AI, and you can see this up on stage. And this is what really motivated this session from the NVIDIA CEO, Jensen Huang, who really, around about a couple of months ago, indicated the curve we're on. And Steph already mentioned physical AI, and this is where we are now in relation to, we've moved from our perception AI, our generative AI, we've moved from our agentic AI, now we're into physical AI. And how do we merge AI with our hardware, and how do we actually build those non-biased, responsible systems? So I just wanted to make sure that you understood why we've been motivated to do this particular session today. And what we'd like you to do as we go through today is we've got a chance to hear from you from insights. So before I move on to Mike, we've got a chance, if you don't mind going to menti.com and putting in the code. And we'd love to hear some insights that you just got from Steph in relation to some of her thoughts around responsible AI, physical AI. What does that mean to you? So as we go through, we're going to be generating our own word cloud, and we'll showcase this at the end of the panel. So Mike, I'm going to hand the mic to Mike. And we're keen to hear from you, Mike, around the hardware meetups.
Okay.
Yeah. All good.
So about how we started the hardware meetup? Yeah. So a million years ago, there was this idea that IoT was going to be this exciting thing. It feels like that long ago anyway. That was when I was living on the Sunshine Coast. And there was a bunch of hardware hackers that were working out of their garages, and nobody was collaborating because they didn't know that each other existed. And so part of what we did was to create a meetup that met regularly every month. And part of that was for people to share the stories that they don't get to share at the barbecue. So you might be at a barbecue, you're hosting at your home, or your family's over, you've got a few friends and things like that, and you're talking about, I don't know, footy or something like that. And then something comes up, you're like, oh, now's my chance. Now's my chance to explain to people that I built a wind turbine in my garage and I'm modeling my new propeller design with blah, 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 and all of these sensors and everything. And you watch as the people at the barbecue's eyes glaze over as you enthusiastically explain whatever it is that you're excited about. This meetup was designed to bring all the people that would actually not glaze over and say, that's cool. And then what happened? And so we created this really exciting meetup. We ended up getting about 40 regular at all times, but I think there's like over 300 members. And the most popular session, we'd have someone would present something that they were passionate about. And then after it, we had the show us your bits session. And that was where you brought out all the things that you were working on. We had all these tables and people could bring out the little projects they had. So many collaborations came out of those sessions. people like, oh, I didn't realize you could do it that way. I was doing it this way, and things like that. And people started building much more advanced, much more collaborative projects. And what's interesting is some of those people who met each other through those events are now off running huge robotics startups in the States. Like one in particular has just raised 30 million. And like, these are all things that have happened. And it's not necessarily that they wouldn't have happened without that meetup, but a lot of friendships were made in that process. A lot of understandings were made in that process, and it's actually translated to real outcomes in a commercial sense as well.
Did you want to mention some of the great projects that you've worked on? We spoke about that, the sports one.
Oh yeah. So prior to working on Rainstick with bioelectrics, I was actually working for player mental health and we trialed it with the Premier League Football Club in the UK, and this was around protecting young people through major changes of identity. So like when they've been in the academy and they think that they're going to be a pro football player, well, only 4% of them actually manage to get to that stage. So that's 96% of them that have this dream of who they think they're going to be, and then that's all of a sudden different, and they're back to wherever they started, before they started that journey. And that could be 10 years. That could be 10 years. They could have come from another country, moved there to work on it. And so one of the big challenges was around how do you do that sustainably for hundreds and hundreds of people? You can't just keep putting more therapists into that situation to handle that identity change. And so we actually built a chatbot for that was around, it was called the Player Advocate. And one of the exciting things about that was we got to actually build it from first principles on mental health first aid. This isn't physical AI and such, but it is something where when you start with an intent of building something for a specific purpose, you can get like really amazing results from it. I did actually want to though point out that we're here talking about hardware AI and physical AI, and I wanted to bring up this one particular point. There was a point in time where it wasn't about the operating system race. There was the hardware race. Like people were building computers, and you have an IBM or all the other older computers that were around at the time, and everyone was fighting over the hardware side of things before the operating system race started. And it was about who had the best operating system. Hardware is in that stage now. There's $175 billion worth of robot work output in the US alone each year. And often they're trained to do a very specific task. I mean, even that cool robot over there, it's doing what it's told to do. And if you think of when you open up ChatGPT and you ask it to make a rap about your dog eating your homework, it wasn't actually specifically trained on that. Potentially, actually, I'm not sure. It is the internet, but it's about the generalized adaptation of knowledge. And so that adaptation of knowledge, if you apply that to then physical systems, so you can have a robot arm that knows how to pick something up, just the same as you know how to sit in that chair. You can sit in that chair. You can sit in the wooden chair. You can sit in the cane chair. You might need to apply some thinking to get into those chairs over the back there, but it's that ability to have that generalized knowledge that's coming for hardware. And that's going to be as significant, if not more significant, than anything that's ever happened for the software operating systems that run our PCs and our phones.
Amazing, thank you. Great insights there. So again, please feel free to add all your insights up into our word cloud. We're going to hand the mic over now to Darren, and I think we all need to understand a little bit more about what is the CANS Manufacturing Hub, because you've got lots of interest in hardware here. And also, how are we building that pipeline, and what are some of the pathways that we can learn from you around the CANS Manufacturing Hub and those type of resources?
Thanks.
Excuse me.
So not as exciting as Mike as well. So I don't think the word exciting really comes into our vocabulary. Queensland government about 6 years ago saw the need to promote manufacturing throughout Queensland, and they came up with the idea of really engaging with manufacturers, which the Queensland government or governments generally don't do that well overall. So in late 2019, they come up with the idea of creating the manufacturing hubs. The first three were Cairns, Townsville, Rockhampton. And over the last 6 years since they were created, we've actually now got 6 hubs across Queensland, right down the coast to the Gold Coast. And basically we support the growth of manufacturing in regional areas. It's kind of a bit vague about exactly what we do, but basically we sort of split it up into talking to manufacturers and just finding out about what they need, what support they need in their regions, whether it be training, if they've got skill shortages, whether it's machinery, whether they need funding. So the model was sort of refined over a couple of years, and what we've came up with was really supporting the businesses mainly to start with skills development. So we actually have, each hub has 2 main staff members, being the manager and a skills development and training officer. And the 2 of us sort of go out and talk to manufacturers and find out exactly what we need in those fields. So we work with manufacturers to say, okay, we're putting in new machinery, but we don't have skilled people either in right back to the basics with welding, or now as we're getting into more technical areas, the people that are putting in robotics, putting in CNC machines, that there is actually no great training that happens in Queensland or in Australia in general. So we work with organisations like TAFE, JCU as well, and come up with courses and that can help and train the skill shortages right across manufacturing. And there's manufacturing right from food, marine, aviation, general steel fabrication, anybody that sort of classes what is classed as manufacturing right across the region. So developing that module now, or the footprint of what we do, we've now got a 10-year roadmap that really sets out how we support those businesses. So we're dealing with mainly businesses that are up and running. So a lot of manufacturers may have 1 or 2 employees, or they may be only going for the last year or 2 and they're trying to still be a startup. There's support that we can give those businesses. It's not physical support from us or financial support. What our model has really looked at is the businesses that we support mainly are the SMEs, so the businesses from 5 to 200 employees. So our grants programs are mainly put around those sort of specifications. But it's looking at the businesses that want to move into advanced manufacturing. So we've got quite a few businesses throughout the Cairns region that over the last 6 years have applied for grants and done incredibly well with grants and putting in advanced machinery and everything from, as I say, from CNC, robotics. The AI side of it's growing, but it's still not huge up in this region. I think we've got 1 company up here that's actually put in a sorting robot that actually sorts physical metal pieces into categories. It also does quality control on them. And they've incorporated that into their business incredibly well. But that sort of is still growing up here, and it's not a lot of businesses that have the finances to sort of outlay to get into that. But obviously the grants programs help. So we're just trying to grow what we do as a footprint and listen to manufacturers about what the next 5 to 10 years is and how we can help with the training. And we obviously support that financially as well with our CAD, CAM, CNC training. We do put that, or TAFE run that for us on those certain courses, and we fund that as well. So it may be a $5,000 fee or a $2,000 fee, and we'll usually fund 75, 80% of that to put employees through it. So we do as best as we can. We're only a small team, and we've got a fairly large footprint that we cover from Tully out to, or sort of north to Mossman and up to Mareeba on the Tablelands. It does cover a lot of industry, so it is hard sometimes for us to get out and meet everybody in every industry, but as much as these sort of forums and sort of areas help us to get our word out there and how we can help manufacturing advance in our region. That was it.
Amazing. And how do we get in touch with you? How do we connect, and how can we be part of what you offer?
We obviously through our own website, it's now Department of Natural Resources, Mining, Manufacturing, Regional and Rural Development. So we've got a wonderful new title now. But if anyone will Google the Queensland Manufacturing Hubs or the Cairns Manufacturing Hubs, there's the contact details on the websites. There's also some basic ideas about what we do and how we promote ourselves, and then the sort of the courses that we offer. But the easiest thing to do really is for the hubs is to pick up the phone, give us a call, and we generally come out and see you, and that's what we do very well, is we're out on the road all the time. Just calling in on the businesses that we deal with and businesses we may not have heard of, and just getting into the regions and finding out more on what we can do.
Amazing, a great resource for us. And I know that we've popped the link is in the chat for those online that want to connect. And you mentioned grants as well. So all the grant information is on the website in addition. Excellent. What a great resource. Fantastic. Make sure you continue to network with Darren after our panel. Moving on now to Alan, we've got Energy Queensland, and I'm really curious. We've had the opportunity to bring a lot of our interns. You also have some great graduates and also alumni that have joined MIST and microgrid team. So I'm really curious. We had a chance to visit you recently, and you had your simulator, supercomputer, everything that's going on. So we're keen to hear a little bit more about where you are in relation to the simulation AI space, but also in the future, where do you see microgrids and IoT?
Cool. So that's a very
Loaded question.
very loaded and very broad question. So I guess just a bit of history. So with the MIST facility and the microgrid isolated systems test facility, bit of a mouthful. That facility, as well as the innovation lab, we've done over the last probably 16 years. We've done lots and lots of testing of different products. So new products. So back then it was things like battery systems, EV chargers, electric vehicles, all that type of those fancy new technologies that that are becoming more mainstream today. So I guess speaking about AI, a lot of that is kind of very relevant to what we do because we see it as just basically new technology, a new system that's coming in to maybe improve the way that we do things or be embedded into existing products to improve how we interact with it. So definitely in terms of our test labs and the approaches, it's very important to continue that type of testing. And fortunately, I guess even going back a little bit further, we were very strong advocates of things like the engineering IoT program. I guess my predecessor, Michelle Taylor, was a very strong advocate of IoT because she saw what things like big data, data analytics, machine learning technologies and what that meant for engineering in general. And unfortunately, those type of things are still becoming embedded into a big corporate business like Energy Queensland. So I know AI is very broad, but we are seeing slowly machine learning, big data, all those type of coding type of skills slowly becoming embedded into the company. And with that, will continue to grow because technology is advancing at such a rapid pace. Some examples of that, we are seeing a lot of these different algorithms come out that hopefully makes the analysis of the power system easier, and through that you make better decisions on how to operate and control the network. So it may not be physical AI in the sense of a robot or something like that, or an actuator, but it could be something that the results of an AI or machine learning algorithm will be used to make operational decisions on the network. And we are already seeing that now. One of the big challenges that we have, or in I guess a traditional engineering sense, is how do you validate and test that? Because those traditional approaches which we use to test new control schemes and new algorithms is primarily based on more deterministic type of systems where a set inputs leads to an output. But something like AI, it's much more complicated because how the AI is trained, and essentially it's a black box to us. So as Sam mentioned, we have invested a lot in our digital simulation. So our real-time digital simulator, which is a big supercomputer, as well as big amplifiers, to basically bring about a new way to test these type of new schemes. So I've been a strong advocate of things like black box type of testing, where we want to create a digital twin of the system, and then use that digital twin to really stress test these kind of black box algorithms or AI systems. So, and that is still progressing, but yeah, I think we're definitely seeing, you know, from the electrical engineering space, there's a progressive advancements of skills that need to be embedded into the traditional engineering sense. So as I mentioned, things like the big data, coding skills, machine learning, understanding, and that type of stuff. So yeah, and that's, yeah, and fortunately we have a lot of the amazing graduates come out of JCU Cairns. So Wilson, Talia, Jai, Ash, all those grads come through, and they're bringing brand new skill sets that sort of traditional power system engineers like myself, like we never had. So
Amazing. I have one last question for you. If you were to glance 10 years ahead, Energy Queensland, physical AI, what's your vision? That's my wildcard question for you. I'm curious.
I hope to see AI, I guess, more broadly being embedded in everything that we do. And even now, I'm a very strong advocate of, you know, if an engineer needs to write some code, I basically say to them, you should probably use ChatGPT first, because it's probably a much more efficient way to generate something, to generate some code and do something, and then work off that. So I would say ChatGPT or DeepSeek or whatever you want to use will become more and more embedded, and it will form a key part in engineering activities. We are already deploying things like Copilot through the business. So you'll find that most people will start just using that from a corporate sense, as well as, you know, engineering activities. As to whether you'll see robots undertaking electrical work, that type of thing, is probably a bit far-fetched in 10 years. But I can definitely see algorithms. So we are all, one of the biggest issues we have at the moment is there's so many different algorithms out there, a lot of different developers, companies that bring out these new algorithms that can do anything, right? That's what they say, that's what they claim. And it's very hard to really validate all of those different algorithms. And some of the algorithms are, as I mentioned, like black boxes to us. And so from a traditional engineering sense, there's probably a level of due diligence that we have to undertake to make sure it's safe and it operates correctly. So yeah, I guess without waffling on, I'll say that the physical AI of robots and stuff like that is probably a bit far-fetched in 10 years, but definitely there are key concepts of AI more broadly that is currently being embedded and will continue to be embedded.
Great future ahead. All right, Steph wanted just to mention, we're having a conversation, Alan, as you were talking about the great graduate program and the opportunity with Energy Queensland. So wanted to make sure Steph got a chance to have a chat about that great success story. We've had many over there, so over to Steph. And congratulations to Mike. You have been, I think, the Rio Tinto founders, no? It's all out.
No, it's on LinkedIn.
It's on LinkedIn.
You can say that one.
Yeah. There's a big announcement, if we head to Steph's question, that Rainstick has been selected. Rio Tinto has the founders factory. That's the word I was looking for. The founders factory. And it's called the Hardware Accelerator. And Rainstick, I think, was the only one in Australia, or was there two in Australia that were selected? I think there were two in Australia that were selected. The others were from around the world. And this is big. This is Rio Tinto's, founders factory. So wanted to give a big round of applause to Mike before I got that news this morning. I only found out that this morning and I wanted to announce that. So let's hear about more success, Steph, from that great program that we have with Energy Queensland.
Thanks, Sam. So yeah, we send a lot of our graduates to Energy Queensland as well as to other companies around Cairns. And what that all stems from really is that for about 10 years now, we've run an Internet of Things program. And while this sort of term of physical AI is being presented as if it's a new concept, if you look at the posters behind you that we made 10 years ago, all of the elements were already there. We were talking about interfacing peripheral devices, sensors, with phones, with cars, with homes, when we started this program. And even before that, because this program was a rebrand of my own degree, which was computer systems. And we covered that sort of thing there as well. So all of these skills are something that we're actually upskilling people in our region to then send to companies like Energy Queensland who need these skill sets to move us towards things like net zero, like advanced microgrids and that sort of thing. So yeah, I think in addition to a lot of the stuff that's happening with the manufacturing hub and TAFE, there's also upskilling opportunities in the engineering sector, sort of here in Cairns through what we have to offer. There was something else I was going to say as well, and it's escaping me now, so I'll let you know if it comes back to me.
Fantastic. I'll just hand the mic back over to Mike to basically sum up what some of your thoughts or insights around physical AI in the future.
Yeah. Probably one of the things to realize how impactful this is that we learn by sharing. Like as humans, we learn by sharing information. And if you've got a robot that's on a production line and it's doing something, and it may not even be a robot. A robot's easy to imagine, but it might be like, you know, sensors and things like that. And it encounters a scenario where it has to make a decision. And it has to use the generalized knowledge it has of the world to make that decision. And if that decision that it makes is then a positive decision, that's immediately shared to the other 200 robots that are along that assembly line. Just like us as humans have managed to, you know, adapt to all the scenarios that we've adapted to over, you know, all the years that we've been on this planet, through sharing of knowledge. And I think that's something to really understand how impactful that actually is when the machines are able to share the knowledge, not just make the decisions. And also to the point around the black box as well, which is a really interesting piece, this digital twin. I mean, when we're making hardware, we send it off to hardware testing places because we don't want to wait until it's been in the sun for 20 years to know whether or not it's going to degrade. We put it in a machine that simulates scenarios like that. When we're, you know, if we're building something structurally, we have, you know, shake simulators, we have all kinds of different simulators for hardware. And building a digital twin is a software simulator for the decisions that it can make. But the exciting thing about bringing that to the physical world is that once it's made that decision, it doesn't know the difference. It doesn't know the difference between whether or not that robot arm actually moved or if it just decided it should move. And so that barrier of consciousness, you know, isn't there. And that allows for then, even in simulated environments, for us to actually handle all the edge cases. Because as much as we like to think things can be deterministic, the real world is not deterministic. If that was the case, then every piece of hardware we ever purchased would do exactly what we thought it would do all of the time. And that just simply doesn't happen. The other point I wanted to make was at Rainstick, we actually, because we're working with plants, so a bit of background, we are bioelectrically stimulating plants to change the way that they express themselves and grow. And we've been successful in securing trials with 4 of probably the top 10 vegetable seed companies in the world. And we're doing that out of, you know, an old pie factory in Bungalow. So, and the reason we can do that is because we've been engineering first right from the start. So all our analysis and things like that, they're all done through specific models that we've trained to do that. We've built our own tooling. We have, for the photographing of seedlings and shoots and things like that, we have these rigs that we've built, and then we do computer vision on there to take all the measurements, because we don't have the luxury that universities have, which is low-cost students sitting there with rulers. And that's actually been the way that it's done for a really long time. And so when you're trying to do things at scale and you're trying to push through, like we've done, I don't know what our number is now, hundreds of thousands of seedlings that we've grown. And there's no way we could do that with a tiny team of 9 if we didn't embrace the technology and the AI in order to do that. Where I see us transitioning to is we now have so much data. We have millions and millions of labeled data points. It's actually too much for us to do the analysis on and still decide what is the next experiment we should run. And so, and as we start getting other transcriptomics, metabolomics, and other information, correlating those things together, it just becomes a huge, huge task, and we just don't have the people to do it. I'd like to see us transition to a point where the experimental design, and this might not be possible, we'll try. The one that decides what experiment we do next is actually an AI, and we follow what it says to do. And that'd be an interesting transition to get to. And at some point, as we build so many of these machines to capture the data, to feed back to that engine, that needs a whole bunch of hardware, that needs a whole bunch of smart thinking, and it needs people to actually build that. So we're actively hiring. We're almost always hiring. So if this is something that interests you, like the advanced, the interface between software and hardware, and building systems to feed the future of the planet, then get in touch.
Fantastic. Great inspirations. I'm going to hand the same question to you, Darren. So if you were to think about, what's your biggest takeaway or insight, and what does the future look like in the manufacturing field? Wildcard.
So the two things we kind of get excited over is the skills development and training side, which again, we have our staff member in Cairns, and some of you may know, I think I've met Alex before, and Alex straight away come up with Sandra Scarcella. She's an amazing staff member of ours, our skills development and training officer. So what we're really excited about, it splits into two. So our skills development is, we work a lot with the Business Liaison Association and a couple of other organisations as well to develop the next generation of people that are working in manufacturing, whether they be engineers, whether they be boiler makers, fitters, turners, sheet metal workers. But the exciting part that we do is we have the careers expos, and to have the students come along to either our careers expos or the careers expos that the organisations like the BLA run, and see the exciting faces and students and kids that just weren't even sure what manufacturing is or what careers are available in manufacturing, to see them get excited about the careers and what actually the opportunities is. And it's not just being a welder, or it's not just being dusty and dirty and hot. There are so many careers in manufacturing that these kids are getting excited over, and the opportunities for them are just growing and growing as technology grows, as we've got some great companies up here in North Queensland that have put in robotics, cobots, sorting machines, CNC machines. So the technology is growing. So the students can see that there's other opportunities other than real physical, hands-on, dirty manufacturing. I mean, that will always exist. But our drive, seeing that passion or that interest from those kids moving forward is incredible. The other side really is what we do with the grant funding. And yes, we just supply some money to some businesses that have the ideas, that come up with what they want to do, the machinery they want to put in, the processes they want to put in. But once they've applied for grant funding, we've maybe helped them with the funding project itself as well, and how it's actually going to be effective for the business. Once that funding goes through and they put that piece of kit in, and we get to go and watch how that business is now transformed, either in a small way or some businesses in an amazingly big way, how that business has changed, how it's grown, how it's employing more people, how it's grown, that sort of the products that it can actually produce, or the range that it can produce, and certainly the speed that they can produce. We've got companies, and if you don't mind me mentioning a couple of names, companies like Cairns Steel Fabricators, companies like Norweld. Every time we have a careers expo, we had our Manufacture Your Career breakfast recently. We had 260 students come along to the breakfast to listen to a panel of local manufacturers to talk about their careers and their products. And everybody's interested in the bigger companies like the Norweld. It just gets an amazing interest from students during the breakfast and also after it as well. And then leading on from that, there's so many student tours that we have through those businesses. But it's exciting to see, the little changes that we can make. But it's really exciting to see the future of who the next people are coming in, the next people coming into manufacturing, and also what the machinery is and how businesses are advancing up here in North Queensland. And a lot of people don't hear about, actually probably most people don't hear about what's actually happening in Cairns in manufacturing, and what major steps some of these businesses are taking and hitting goals. They're not only supplying to businesses around our region, they're supplying nationally, internationally. And part of that is, that we've had a small hand in that as well with our grants program and our training programs. That's it. Thanks, Sam.
Yeah, amazing. And that's why it's so great to have you here so that we can continue to share that great work and inspire. Just looking up at our word cloud here, collaborations growing and growing and growing. So in the spirit of collaboration, I want to extend questions out to our online guests and guests that are here today. If you have a question, please, I think it's a great time to, again, we've got some great resources and very talented professionals here today, and we've got so much to cover in relation to opportunity. But if anyone has a question or would like to share insights, please keep adding to our word cloud as we've been building today. Any questions?
This is a question for the whole panel. I mean, the person who knows or would like to answer this, but I read a book, I'm reading a book right now that's called The Coming Wave, and it talks about how robotics these days are very much like just they're working in verticals. They don't really multitask. Like, for example, you can have a robot that moves something from one place to another, but you can't have a robot that cooks you a meal. How far do you think we're off from actually robots being introduced to households where they can multitask? So, do other things than cleaning, do other things than just moving things around. Does anyone have a sense of where things are going or what we should be expecting?
Right.
I can talk to that.
Yeah, you can talk to that.
There you go, Steph. Over to you.
So I actually
pass it
think a lot
down.
of the building blocks are already there. A lot of the technologies we would need to actually get robots into household and say cooking a meal, they already exist around things like computer vision. We have the actual finer robotics as well that could handle the motions. It's more about the cost of putting it all together and actually deploying it. So I think feasibility wise, like you give someone enough money, we could probably build something like that now. We're still a long way off that being something that would actually be able to be widely deployed into households because it's not an easy thing to do or a cheap thing to do.
I was just going to say, I guess, in my career with testing products and new devices and that type of stuff at Energy Queensland, it always, when I first started, I was things like batteries and all that was a new thing, or solar was even sort of new at the time, and the trajectory of technology has by far exceeded my expectations. Like I remember going back 10 years in these battery conferences talking about sodium ion batteries and that being like 20 or 30 years away at that time, and now we see mass manufacturing of them by companies around the world. So I'm sort of now I kind of feel like the technology will continue to advance at rapid paces, and we see that now. Just processing power is just becoming immense. Cost of CPU power. So it wouldn't surprise me if you see humanoid robotics coming into houses and to cook your meal. It's just things that are it's just unpredictable at this point.
There's a lot of general scenarios that aren't covered in that. So like you're saying, like a lot of the gear is already there, but it has to handle, a child running up and grabbing something and moving it, or all of those other kinds of edge cases that's very hard to test for. But I think the real thing there is we've all, like, I don't know, I remember the Jetsons. I don't know who else remembers the Jetsons. The assumptions that they actually made in the Jetsons.
Yeah.
So when the robot actually had to make a phone call,
Yeah.
they grabbed a corded phone with a curly wire. Like there's a lot of assumptions we make with how we think robots are going to be integrated into our lives. But by the time they arrive there, the things that we assumed have also changed. And so if the Jetsons were to be made now, there wouldn't be that wouldn't be what the phone looks like. So I think getting it into consumer scenarios, it's going to start with industry first, because that's where it can have the biggest impact. That's where you can create. Is there a standard operating procedure for making spaghetti bolognese? Ask an Italian and the answer is yes. But generally speaking, an SOP can be implemented into an industry, very hard to do in a consumer home where you can control those environments. And this is the wave that we're seeing now. As that generalization starts to become more available, those things that were previously impossible, well, impractical, not impossible, start to become possible. And as we start having systems able to optimize themselves, we can start baking that down. I mean, we had Coral AI years ago, which was a AI on chip, like system on chip situation. When that can be deployed at edge, when all these decisions can be shared instead of it being centralized, all of those kinds of things, we will get there. But I wonder if the real question is, why don't we have robots making spaghetti bolognese on Mars, as opposed to making it in our kitchens when we're perfectly capable of doing that?
No.
Great answer to the question there. Any other questions we have from our on-site audience? Anything online? Yep, fantastic.
So in the context of regulation and liability, who should be held accountable when a black box, for example, a black box AI in physical form malfunctions or makes harmful decisions?
I got it. Thank you. Who's going to take that one? All right, yes, over to Energy Queensland.
Yeah, thanks for the question. That's probably the thing that kind of worries me with AI.
Yeah.
I know we're speaking a lot of positive things about AI. I guess being the devil's advocate, there is a lot of the whole responsible AI and the whole standards, guidelines, policies, that type of stuff, the boring stuff that hasn't quite been worked through. So I'll give you some examples of things like the black box AI, and it may not be AI, it just might be because it might be a complex system that does something, or the supplier says it does something, and they claim it, but you don't really know because you can't really check, right? Because these algorithms could be, immense. So, and this is, I guess, going back to digital twins and the importance of digital twins and that concept, because it's not inconceivable that sometime in the future, you'll need an AI to test an AI, or an AI to validate an AI. We see that now in terms of cybersecurity, where you have, AI that's out there that are basically hacking through systems, and you need an equivalent AI to kind of combat it, right? Because AI is powerful, it's trained to do a task, and it does a task very well. And I guess normal humans, I think we can't fully understand what an AI can do. So the approach is to use another AI to validate. And I see digital twins being that type of concept where you keep the AI or the black box machine in a very controlled environment. And we do that now with things like, one example is we're doing a lot around diesel generator controller testing. So we have a box, off-the-shelf box that we buy to control the generator, and we keep that in a virtual environment to mimic what a diesel generator actually does, and then we can test thousands of different scenarios safely. And you test all sorts of things that the supplier promises, and some work, some don't, and you work out all the defects. So I think the same sort of concept applies to AI. And there was a funny story that we were talking about things like cybersecurity checks and scam emails, and they're basically saying that now, because everybody's using AI, the normal indicators of a scam email, which is, spelling errors or like just unusual things in the email, is no longer there. Those emails are perfect. So now that if you have spelling errors in a scam email, more than likely that is actually a scam email. So it's kind of everything's gone back the other way because AI is everywhere, and yeah, how do you verify, test it responsibly?
Just before you go, real quick question: who's responsible now, even in a human world? The insurance companies. There could be an opportunity for insurance to grow significantly for policy in that particular department, because we tend to just come up with more systems to pass the buck of responsibility. But that's more of a commentary.
I think that's essentially going to be the answer.
Yeah.
But no, I researched this question a little bit. I did a paper on responsible AI, and I looked at what government, industry, and academic sources think the answer to this question is as part of it. And it's pretty 50-50 between the AI itself and the company or the engineers who've developed it. I think more realistically, from a like who could you prosecute if something goes wrong perspective, it is going to be the companies, and that is going to be things like having insurance so that when your product fails, you can essentially pay people out. That being said, I think the better approach and the more responsible approach is to try and prevent things from happening in the first place. And that again goes back to things like Alan was saying about having digital twins so that you can actually see how your system is working. It also goes back to things I was saying earlier around having the AI explain the decisions it's making so that you can kind of detect early if it's doing things that don't make sense. Like if you're self-driving cars deciding to run over 5 pedestrians instead of swerve into the tree type thing. So yeah, I think having those layers of explanation allow for that auditability that prevent things from going wrong as often. But ultimately, it's going to end up being companies and individuals that have to be held to account, because the AI is just a dumb algorithm on some hardware. It's not actually able to be held legally accountable for anything it does.
Great insights. I've got another question over there. Great insights there. You have a question here? Yeah.
I was just going to contribute in relation to that because I practice as an AI IP lawyer on the accountability and the transparency and everything like that. And so what you're actually seeing is the EU's taken the lead, whereby they've enacted the AI Act in the EU. And they split it up into 4 tiers of AI technology. There's tiers 1 through to 4. And generally speaking, tier 4 AI is AI that makes decisions of itself. And a lot of regulations now being put into that where they're looking at who is going to be responsible and whether it's going to be allowed. So what you're looking at is the top 3 layers all have human responsibility before it actually goes out to public. And so therefore the human who is the one that signs off is going to have that responsibility. And so they're going to be the ones that are accountable. In addition, the overlay there is that a lot of European companies now have to comply with that act. And so what they're doing is the similar line to with ecology and doing the tracing through right through to the very primary producers. With AI technology, they're saying you're going to now have to go through and be able to prove what the benefits and detriments of that AI technology are, and they have to be passed through. So if you're at that startup phase, you should really starting to be taking note of those things, because before long, you're going to need to sell your product, and to sell it, you're going to need to explain to the purchaser what are the positives, the negatives, the detriments, the shortcuts and efficiencies that can be done, because these need to be paid to the consumer in order to get that result happening. And so then the other argument, the other side of the equation is like Donna Patani is here as well, we're IP lawyers. And so the biggest question is around who actually owns the AI. And at the moment, the argument and consensus is if you develop the AI, if you put the input in and you actually take the output, then you will own the output. If you don't own the AI system, but you put in the input and someone else takes the output, it's unknown. So that's where it's going to come down to, when you're selling your AI product, that you have a good terms and conditions and a good AI policy and a good insurance policy. As you know, Stephanie was saying, you have to have those things in place in order to be able to sell this product properly. Otherwise, you're going to find yourself on the back foot. So while it is great with all the stuff, there will be costs involved in getting that product to market in the AI sphere, which is why you probably haven't seen the commercial side of things happening, because as Mike was saying, the industrial area is able to pay for these things, and so they can get them and they can justify the costs regarding the legal and the frameworks and accountability more so than the other areas.
Thank you. Excellent. Sounds like we have to have another panel on responsible AI and IP. Ellen, do you want to add a comment there? Yeah.
Yeah, that's a very interesting point about the legal ramifications. I know from my experience in sort of the power system and operators who operate the power system, I know that that type of having a human oversight on top of an engineer, on top of an AI or output. I sort of question that a little bit, because for me, AI is, I guess, is no different to a complex box doing something. And at the moment, we have challenges now with the power system being much, much more complicated than it ever used to be, with solar farms, batteries, and that type of stuff. So, and for them, sometimes if you say to them, those operators, that they don't trust this box, but you need to take responsibility for an output of a system that you don't quite understand, and you have to make a call to accept it or not accept it. And it's like a life or death situation, or it's a system stability situation where you could lose power. I think that would be a very hard sell, because at the end of the day, you can't put in a system that requires someone to constantly check what it's actually doing to make sure that it's safe. I think the system, the AI or whatever the box is, it needs to be inherently safe. And I don't think they would pass the kind of, the engineering due diligence that we would have to do. I feel like it'll be up to the engineers to, I guess, set a high level of safety around that box. And they'll have to do that through more complex testing means to make sure you cover all, 99% of scenarios, is my feeling around that.
At what point will
We
we
need
be
a new
asking the
panel.
question whether or not AI can be self-sovereign? And how will that actually change that whole conversation
There you go,
when that
yeah.
happens?
I think we're a long way off that. But I also think it's an interesting point around what actually counts as AI as well, because I've certainly seen some research papers that have called linear regression AI, and linear regression is y equals mx plus c, which we all did at some point in middle school. So it's, where do we actually call something AI? Where do we just call it advanced software? Because we're already using advanced software for control systems. And there's probably not quite as many layers of legal question around that. So yeah, I think that's an interesting piece of the puzzle as well.
Fantastic. I think we can continue on this topic for probably a longer time. And I think we should park it here. We're out. But I think only because we've got other presenters and we've got lunch on this side. So, but it's fantastic that we've had so much interest and so many great questions. Can we please put our hands together for the amazing panel? And we really, really appreciate you taking your precious time, that we've planted on your behalf a tree with your name, and you'll be receiving a certificate. Mike, I think this is your second tree that we planted in the Quinlan Forest in Sunshine Coast. And so instead of giving you a trophy and a certificate, we like to plant a tree for you with your name that really serves as the opportunity to make sure that koala food trees continue in the Harold's Forest. So a round of applause for you and your trees. May you grow and grow and grow. And really appreciate the level of expertise that we have here in Cairns. And what a great opportunity to kickstart the hardware meetups with us. So thank you, and look forward to continue conversations over lunch. We're now going to move into our next phase. So thank you very much. So what we'd like to do is have a discussion more around, we've heard from expertise, insights, what we should be looking at for now and the future. But what I'd like to concentrate now on is the resources that surround us as innovators, as inventors and founders. And we've already heard from our panel what type of insights we should be thinking about, but what we want to do now is find out how can we put all that into action. And then obviously we'll have a chance to have some lunch and continue on those conversations. But wanted to see, is Joe online?
I am indeed. Can you guys hear and
Absolutely.
see me?
Fantastic. So, Joe, I've got the ACES screen up on our atrium screen here in Cairns, and really wanted to hear from you, Joe. Really, we had the opportunity to have this discussion when we were at the Consumer Electronics Show this year, and you've gone and you're the president of this new society that basically has launched in Sydney, where you're headquartered, where the Australian Creative Electronic Society is headquartered. We're launching in Cairns today, and tomorrow launching in Melbourne. So
Correct.
yeah, taking Australia by storm. So round of applause. Amazing, amazing, amazing. So
Thank you. Thank you.
Joe, I'm going to hand the floor over to you now just to have a quick discussion, because following you, we're going to also hear from other societies that we have here, including IEEE, ACS, and also the Cairns Engineering Society. So the floor is yours.
Fantastic. So I met Dr. Sam in Vegas earlier this year, in January, at CES. We were one of the few Australians there in an unofficial sort of tourist delegation, right? And I was actually one of the 4 delegates there actually exhibiting a product. And I thought to myself, hold on a second, everyone in Australia, like there's so many people in Australia, there's so many people building really cool hardware. Where are we? Right? Can I get a hands up in the room who's working on hardware?
Yeah, there's a few here, yeah.
Right, yeah. So
40%.
and in Sydney, we've managed to run 2 events so far. Last one, 155 RSVPs. There's just so many hidden hardware gems in Australia that we're not exhibiting to the world, and where countries like South Korea, like Singapore, China, Taiwan, America, Canada, Netherlands, most OECD countries, even Ukraine, in the midst of a war, sent a big delegation there to exhibit their cool products that they're working on. Where is Australia? And so that was the question that was really front of mind for me and Dr. Sam here, so much so that we've kicked off ACES, which is Australian Creative Electronic Society. Now, our main North Star is to just get more people to CES, and by doing so, increase Australia's hardware presence on the world stage. I don't think we lack talent. We just lack the visibility on the world stage. And so that's what ACES is here to change. Get us onto the world stage, stop being so insular. Let's take the world by storm, because the capital, the consumer demand, the business demand, it's on the world stage. Australia is not a big enough market, so we can't be so insular. So that's ACES' goal. I'd like to invite everyone to join. We also have a very supportive Slack community online that's national. So people from SOFA, Cairns, Melbourne, and Sydney are able to connect. We do want to expand nationally. It's a very supportive society. You ask questions, you can find jobs, you can just have a chat about what you're working on across the country. So yeah, we'd like to really get more Cairns members on board. So I'll share my screen now if you guys could see it. There'll be a QR code where you can scan, and you can join up to the society today for free. Thank you very much, guys.
Thanks so much, Joe. Round of applause. And it's been great working with you and the team and all the founders of ACES, and an incredible society. And Vicky's here, who was part of the Australian delegation with you at CES. So she's here in the crowd today. So I think we're on a mission. I think we can hear that we've got all the ingredients, we've got all the components of the ecosystem. We have the expertise, the leadership, the inspiration. So I think we've got a great opportunity to really work towards this goal. And how many I think places or how many delegates do you think we can send to Vegas next year?
We want to send, yes, we want to sponsor, yeah, we want to sponsor 10 startups to CES next year.
Yes,
Yeah.
from Australia. Yes. We want to see that. Yeah, that's amazing. Amazing goal. And I think with the energy that's created by Australian Creative Electronics Society, and you, I think, started out, I think in like a week, you had over 200 plus registered. So it's really great. So congratulations.
Thank you. Thank you. It was 150, but yeah, pretty
close.
150
was it? Okay. Well, you'll get another 50 from Cairns.
Thank you. All right. Thanks, everyone. Back to you.
Thanks, Joe. Really appreciate it. So what we'd like to do now is move from the Australian Electronics Society, and let's hear from another society that can actually help you in relation to resources. We've got the Australian Computer Society. So we've shifted from hardware back to software, but we have Dr. Kranthi here to talk about the CANS chapter. Again, another support, another resource. So I'll hand the floor over to Kranthi. There you go, Kranthi.
Thank you, Sindh. Hello, everyone. My name is Kranthi Adanki. I'm one of the IT lecturers, information technology lecturers here in JCU. And also I'm one of the JCU founders in residence working on digital twin student. As many of the panelists talking about that simulation, I'm passionate about students because every student is unique for me. And we want to give precise education to running all the predictions because we are reskilling and upskilling, and learning is a lifelong journey till 70, 80, 90, we are continuously learning. So we are doing some interesting stuff, integrating AI into education systems, learning management systems. That is what I'm passionate about. And particularly here, today I'm representing ACS, CANS chapter, Australian Computer Society, which is helping computer science and IT professionals running through series of events like industry events, training, and skilling with 44,000 plus courses in their Sophia platform, SIFA. If you could check out the QR code, you could see what are the services available. And membership, you could see for professionals like who are working in industry, IT industry and computer science, it is 370 per annum. And for students, it's free, JCU students. Please use that opportunity. It's a great gateway for your career as we are into the world of AI, Gen AI, where you're working, right? So you might need some skill set. So use this platform for gaining skills free. And yeah, maybe you could give your reviews on national policy around AI and ethics, responsible AI development. That's from my side, representing ACS. Thank you.
Excellent. Thank you. Thank you, Kranthi and ACS. And we'll be also drawing from our winning prize, which will be a membership for ACS. So that's another great opportunity. So thank you, Kranthi. We're now going to move into the CANS Engineering Society. So we're going to invite Ben up to talk about what's happening at the CANS Engineering Society, apart from incredible barbecues. Oh, okay. Well, tell us what's happening. Give us an update. Thank you, and congratulations on your exams, finishing your exams.
Hi, everyone. I'm Ben. I'm the president of the CANS Engineering Society. A lot of you here may know me. I'm here more just to speak to the local industry, just trying to get some support for the CANS Engineering Society. We have some contact information up there if you are interested. Just very quickly touching on, yes, we are a resource as students, as some of the larger players in the room will know, such as Energy Queensland and the government. Most resources you can sort of come up with, you can come up with manufacturing, you can buy stuff overseas, you can print more money, you can always get those resources. The one thing that you fall short on is engineers. And that can be shown by the fact that Energy Queensland offers $20,000 to secure engineers through university. So what we're looking at doing is something similar to that. We're releasing a prospectus soon where you can actually offer to support the Cairns Engineering Society and the student body here to get contact with those engineers, to get a bit more, I guess you could say, interfacing with those engineers, to show them what your company has to offer. And maybe even inspire them to come to work for you as graduates or as engineers later on. And that's all I've got to say.
Amazing. Thank you. Thank you, Ben. And appreciate it because we just wrapped up exams as of yesterday. So really appreciate the fact that you're here. And again, a great resource and a great opportunity. And also to that point is the fact that we have the great chance to work with some of our IoT engineers. I'm just referring to Kim, who studied IoT engineering and has now joined our JCU Founders and Residents portfolio and has launched 2 companies since graduating JCU and has now come on board to start his PhD at work at JCU. So again, that great story of it starts here at JCU and there's sometimes that circular economy of coming back for more. We're going to hand the floor over now to IEEE. So we've got Dr. Yang here, who's going to give us an idea about IEEE. Does anybody know what IEEE stands for? You're not allowed to say, Steph or Lawrence.
Yeah. Hi, my name is Yang Zhu. I'm a senior lecturer here at JCU, and I work on renewable energy, power electronics, and smart grid stuff. And IEEE stands for International Electrical Electronics Engineering. Okay, it's a very big organization. So we have lots of members across the globe, and a quarter of them are student members. So we are growing, and it's a true global organization. Although it's originated from USA, like 140 years ago. Almost as old as electrical engineering. And now we have more than 60% of members from outside USA. So it's a true global organization. We have 342 sections, and Northern Australia section is one of them. So we're covering Townsville, Cairns, and Northern Territory. So we have 2 universities join us, of course, JCU and Charles Darwin University. In both universities, we have students branches. But unfortunately, we have less activity here in the Cairns campus for JCU student branches. So that's why I'm here and try to, advocate for this student branches. In Townsville, we have a robot club. It's a very well-established students organization. We try to have something here as well. Sorry about that. It's a bit twisted. So we have a lot of publications and societies cover almost everything about electrical engineering. For example, Power and Energy Society is one I actively participate. We also have something about medicals, AI, and all kinds of societies. We have plenty of publications in journal and conference papers. And of course, we also have standards. Maybe you heard about IEEE standard in some of the areas, very important. If you want to sell your products in certain countries, then you need to follow IEEE standards. We have lots of conference and events like technical seminars is one of the major form we organize, both in person and online. It's mostly free to all the publics, no matter if you have a membership or not. These are some of the area we cover. We have more as well. So in short, we have lots of members, lots of publications, and lots of conferences and events. It's a great place to meet people, to learn new things, and grow your career. And please join us in the Northern Australian sections. And I'm happy to connect and provide information. In the end, as Sample invite me and offering a free IEEE membership as well.
Yeah,
thank you.
Thank you. Amazing. Thank you, Yang. That's amazing. Just on that point of a free membership, has everybody put their name into the draw? Has anyone not? Because we're going to be drawing a prize for an IEEE membership and also an ACS membership. So everyone has, yeah? So can I have Kranthi draw from here? Lucky draw. Who's that?
Clive Patton from Hello World AI.
Woohoo, Clive! You're the winner of the ACS, Australian Computer Society membership. Where is Clive? Hey, congrats, Clive, you won. Yay, congratulations. Yeah. And Yang, did you want to draw for IEEE? So that's our winners for today. What have you got?
So sorry, I can't. Is that
Ooh,
Tashi?
Tashina from Hello World AI has just won herself an IEEE membership. Congratulations. Amazing. Thank you. All right. So those are our two winners. We're going to finish up here for those who are online because we're going into our demo phase for the event. It includes lunch. It includes the opportunity to hear from some of our founders that are working in the hardware space. We also have some 3D printing demos from NDRIP. NDRIP are actually 3D printing their components on farm. And it's great to see these use cases like Darren shared that are actually putting additive manufacturing on farm with components. So we've got 3D printing, robotics, autonomous systems. Make sure you do the wave up at the entranceway. And thank you for all of our online guests that attended today. And we hope that you receive a lot of great insights and continue to support the work that's going on with the Queensland AI Hub, but also our new chapter for Cairns, our city chapter for hardware meetups. Round of applause. Congratulations. So just to give you a heads up about what's going to happen in this space now, we've got networking, lunch, but we've got a chance for anyone who have a conversation, perhaps with some of the panelists that you had some insights from, some more questions. We have Hello World AI, so Clive and also Jared, the back there, are showcasing some of their innovations, inventions, AI rigs, everything's there to demo. And this is exactly what Mike was saying. These hardware meetups are show and tell, showcase your inventions and innovations. We've also got Dr. Bruce Belson here, who's done some great work with us from IoT engineering and sensors that are out on field, collecting data, big data, LoRa networks. Have a chat to Bruce. Also, we have we've got Clive. Oh, Andres is here from Ag and TeleSense. And we've also met Kim, who's also here in relation to talk about some of his machine learning, Raspberry Pi 5, if you're interested, and also the interface with the avatar that was created by XTech AI, Ismail. So please stay and have that conversation, and please join us for lunch, and look forward to next Connectivity Cafe, which is next week. Next week, we'll be looking at finance and also the launch for the 3-day AI simulator at the Daintree Rainforest Observatory if you're interested. So lots going on, and thanks again to Ramona for all of our logistics. There you are. Thank you, Ramona, for getting everything together, being there. And the Mind Designs team that are running this amazing work, and also our Townsville team that are based with Professor Kerry Russo and Jordan from GRS team. So thanks everybody for supporting us and attending today. Thank you.